Oxidation state or oxidation number of an element in a compound is the real or apparent charge on one atom of the element. The algebraic sum of the oxidation numbers of all the atoms in the formula for a polyatomic ion is equal to the charge on that ion. Neither exhibits positive nor negative oxidation state because it is a noble gas element with completely filled orbitals, that is 1s2, 2s2, 2p6. Moreover, it has no vacant d orbitals. Hello everyone, this is Harshita Bhavasar from Vidhyaashram, PU College Temple of Excellence. Today I am going to start session 2 from the chapter Redox reaction. In the last class, we have discussed so many points or introductory points of redox reaction and what is oxidation, what is reduction, and what do you mean by reducing and oxidizing agent. These are the contents we have discussed in the previous session. In today's session, we will discuss what is oxidation number or oxidation state and how to analyze those oxidation number, that is rules for assigning oxidation numbers. These two content we will discuss in today's session with so many examples. First we will see oxidation number or oxidation state. What is the definition of oxidation number? Oxidation state or oxidation number of an element in a compound is the real or apparent charge on one atom of the element. In one compound, there are 2 or 3 elements will be present. If you want to find out one atom charge, it may be real or apparent. That atom charge, if you want to find out, that identification of real or apparent charge of an atom in a compound will be called it as oxidation state or oxidation number. Example, oxidation number of sodium in sodium chloride is +1, since the real charge on one atom of sodium in sodium chloride is +1. Similarly, the real charge on one atom of chlorine in NaCl is -1 and hence oxidation number is -1. Oxidation number of hydrogen and oxygen in water are +1 and -2 respectively, since the apparent charge on each atom of hydrogen and oxygen are +1 and -2. What do you mean by real charge? If you want to analyze the oxidation number, you have to know that hydrogen will be having +1 and halogens will be having -1 and S block elements will be having +1 and +2 oxidation state. These things we have studied in classification of elements chapter also. Here, if you take sodium chloride, that is NaCl, for sodium Na will be +1, chloride Cl will be -1. And if you take water as another example, in that hydrogen will be having +1 and oxygen will be having -2 charge. Oxidation state of an element in a covalent compound ascertaining according to a set of rules formulated in which the apparent charge on each atom covalently bonded is calculated by giving the shared pair of electrons to the more electronegative atom. If it is covalent compound is present, there are set of rules to assign those numbers on an atom in a compound. So, you have to follow those rules, will be seen in the next coming slides. Okay. Rules for assigning oxidation number. Okay. The oxidation number of an atom in a elemental state, that is uncombined state, is 0. You know, here example C, evidently oxidation number of each atom Cl2, H2, O3, these are all element. Cl will be like Cl2, H2, these are all elemental thing. So, its number like see sodium, magnesium will be 0 in elemental state or uncombined state. The oxidation number or state will be 0. Next rule, the oxidation number of an ion is equal to its charge. Sometimes we will write Na plus Cl minus, see here like that. If it is having Na plus, then +1, Cl minus, 1 minus is there, so -1. Here 2 plus is there, +2. Whatever charge is present on atom, that charge will be considered as oxidation state. Next, the oxidation number of hydrogen in all compounds containing hydrogen is +1. except when hydrogen forms compounds called hydrides with active metal in which it is -1. Usually oxidation number of hydrogen will be +1, but whenever it is reacting with metals like sodium, potassium, calcium like that, it will form hydrides like sodium hydride, potassium hydride or calcium hydride. You know that S block elements are usually metals. So, if the hydrogen is reacting with metals, it will form hydrides. That whatever the hydrogen is present in hydride, its oxidation number will be -1, not +1. Example, oxidation state of hydrogen is +1 in water, but in NaH, that is sodium hydride, it will be -1. Next, the oxidation number of oxygen in all compounds containing oxygen is -2. Usual oxidation number of oxygen is -2, except in peroxides, in it is -1 and superoxides -1/2. Usually oxidation number of oxygen is -2, but in peroxides -1 and in superoxides -1/2. Example, in water, oxidation state of oxygen is -2, but in H2O2 it is a peroxide, so -1. The oxidation state of oxygen in OF2 or O2F2, that is superoxides, that is +2 and -2 respectively. Okay. The algebraic sum of the oxidation numbers of all the atoms present in one molecule of a compound is 0. You know that algebraic equation you will write in the mathematics. What will be? You have to prove equivalent to 0. So, algebraic equation of the oxidation number of all the elements in a compound will be equivalent to 0. The algebraic sum of the oxidation numbers of all the atoms in the formula for a polyatomic ion is equal to the charge on that ion. Whatever charge will be present on element or atom in a polyatomic ion, it will be equivalent to that ion. The oxidation state of halogen in their compounds is -1, but in interhalogen compounds of chlorine, bromine, iodine, the more electronegative of the two halogens gets the oxidation number of -1. For example, in BrCl3, the oxidation number of Cl is -1, while that of Br, that is bromine, is +3. Usually, oxidation state of halogen, that is group 17, will be -1. But if it is present in a interhalogen compounds like mixed of halogen compounds, then one will be more which is more electronegative, that will be considered for -1 oxidation number. Another, the less electronegative element will be considered as whatever the respective ion will be present. When chlorine, bromine and iodine combine with oxygen atom, for example, in oxo acids and oxo anions, halogens have positive oxidation numbers. The oxidation number of alkali metals in their compounds is +1. The oxidation number of alkali metals in their compounds is +1 and that of alkaline earth metals in their compounds is +2. In S block, you know, two groups are present, that is alkali metals and alkaline earth metals. For alkali metals, usually the oxidation number will be +1. For alkaline earth metals, the oxidation number will be +2. Oxidation state of K is K-4 is +1. To find out the oxidation number of other elements, we usually use rule 5 and 6 as given below. Okay. Usually if you want to find out other elements, we usually use 5 and 6. Means algebraic equations you have to use. These are the set of rules to find out oxidation state or number. We will see some of the examples now. Calculation of the oxidation number of underlying atom in the given compound. This is H2SO4. For S, we have to find out what is the oxidation number. What we will do now? That should be considered as X. Let X be the oxidation number of sulfur atom. Okay, we don't know that, so we are representing like X. For H2, what is +1, but how many hydrogen? 2 hydrogen atom is present. S is X, oxygen +4 into -2. -2 is the charge of oxygen, will be equivalent to 0. This is the fifth rule of oxidation, fifth rule of assigning oxidation number, that algebraic equation or equivalent to 0. Okay, the sum of algebraic equation will be equivalent to 0. That's why they are representing. And you have to calculate usually. Okay, 2 into 1, 2 plus x minus 4 2s are 8 minus 4 equivalent to 0. If you take x here, 8 minus 2, what will happen? 6. Plus 6 will be the answer. So, what is the oxidation state? 6 will be the oxidation state. We will see another example in HNO3. We have to find out for N. N will be, now X be the oxidation number of nitrogen atom. For hydrogen plus 1, one hydrogen atom is present, so 1. Nitrogen we doesn't know, so X. 3 oxygen atoms are present, so 3. 3 into minus 2 equivalent to 0. Normal general algebraic calculations, what will happen? X equal to plus 5. For nitrogen, plus 5 oxidation state is present. Another example, Fe2O3, ferric oxide or ferrous oxide. Let X be the oxidation number of iron atom, 2X plus 3. Here 2 atoms are present, but we doesn't know what is the oxidation number of iron. So 2X plus 3 into minus 2. Minus 2 is charge of oxygen. 2x minus 6 equal to 0. 2x equal to 6. So what will happen? X equal to plus 3. 6 by 2. Okay. Next Mn2O7. Here also Mn will be manganese. Bx, oxidation number of manganese will be x. 2x plus 7 into minus 2 equivalent to 0. 2x minus 14. 7 2s are 14 equivalent to 0. 2x equal to 14. X equal to 14 by 2. 14 by 2 plus 7. Okay, for manganese usually plus 7 oxidation state will be present. Next, calculation of oxidation number of underlined atom in the given ionic species. If it is ionic species, what is ionic species? Charges are present, cationic or anionic species are present. So, if it is compound is having ionic charges, how you will find out the oxidation number? Here also manganese, we doesn't know oxidation number. So, X plus 4 into minus 2 equal to minus 1 because ionic charge is present, minus 1 minus 1. Here the algebraic sum will be not equal to 0. You have to represent the ionic charge whatever given on the top of compound. X minus 4 2s are 8 equal to minus 1. If you take 8 here, what will happen? Or minus 1 if you take left hand side, x equal to plus 7. This is carbonate CO3, 2 minus x plus 3 into minus 2 equal to minus 2. This minus 2 will be present here. X minus 6, 3 2s are 6 equal to minus 2. You know x equal to plus 4. If you take minus 2, plus 4 will be present. Okay, we will consider another set of examples. Consider the elements cesium, neon, iodine and fluorine. Identify the element that exhibits only negative oxidation state. In 4 of the elements which will exhibit negative oxidation state. What is the answer? Fluorine exhibits only negative oxidation state, that is minus 1 in its compounds, because it is the most electronegative element. Rules for assigning oxidation number also we have read that for halogens usually it is more electronegative atoms. So, it will be having negative oxidation number, that is minus 1. Among these fluorine will be most electronegative, so it will be having minus 1. Identify the element that exhibits only positive oxidation state. Which one? Cesium. Okay, cesium will exhibit only positive oxidation state, that is plus 1 in its compounds, because it is most electropositive element. It is present in S block elements and in alkali metals, so it will be having plus 1. Next, identify the element that exhibits both positive and negative oxidation state. Iodine has 7 electrons in the valence shell as well as vacant 5d orbitals, to which electrons from 5p and 5s orbitals can be shifted. Therefore, these elements exhibit minus 1 oxidation state as well as variable positive oxidation states of plus 1, plus 3, plus 5, plus 7 in its compounds. Okay. As group 17, it will exhibit minus 1 oxidation number. Since it is having 5d vacant orbitals and 7 electrons in its valence shell, it can exhibit positive and variable oxidation states also. And why these concepts we are discussing means it will be helpful for your MCQs as well as for your competitive examinations. Identify the element which exhibits neither the negative nor the positive oxidation state. Means you have to identify the element which does not have any negative or any positive oxidation state, which is that neon. Neither exhibits positive nor negative oxidation state because it is a noble gas element with completely filled orbitals, that is 1s2, 2s2, 2p6. Moreover, it has no vacant d orbitals. We know that neon or noble gases are completely having stable configuration. So, it does not have any vacant d orbitals. That is why it will not having minus or plus or negative or positive oxidation state. Next, stock notation. The oxidation state or oxidation number of a metal in a compound is sometimes presented according to the notation given by German chemist Alfred Stock. In some of the compounds, metal will be written as in the bracket with Roman numbers. That was given by German chemist Alfred Stock. Representation of oxidation number by putting a Roman numeral in a parenthesis after the symbol of a metal in molecular formula is called Stock notation. Means, see here one of the example. This is gold, which is a metal. Here also stannous is present, that is tin. It is also a metal. After that, in parenthesis means brackets, they have written in Roman numbers. That is nothing but its oxidation numbers. Okay, but they have written after the metal. So, it is representing its stock notation. This is called stock notation. For example, Aurous chloride and auric chloride are written as, here Aurous 1, auric 2. Usually, OUS will be having less oxidation number, IC will be having more oxidation number. Ferrous plus 2, ferric plus 3, like that. Similarly, stannous chloride and stannic chloride are written as, see here, in 2 Roman number, here 4 Roman number. Okay. This change in oxidation number implies change in oxidation state. Okay. Whenever the oxidation number will be implies change in oxidation number, oxidation state will be also changed. This is how the stock notation will be represented. Significance of stock notation. It helps to identify whether the species is present in oxidized form or reduced form. What is the significance of stock notation? You can analyze by seeing the compound, whatever it has written in stock notation, you can identify that compound is whether reduced or oxidized. Okay, see here, mercury chloride, mercury is in 1 oxidation number is the reduced form of with having 2 oxidation number. Using stock notation, represent the following compounds: HAuCl4, Fe2O3, CuO. Solution: by applying various rules of calculating the oxidation number of the desired elements in a compound, the oxidation number of each metallic element in its compound as follows. Here they have given 3 compounds. We are considering or we are calculating its oxidation number. Here for metal Au, right, 1 plus, this is hydrogen, gold and chloride. You know now how to calculate oxidation number. For this plus 3 will be present. For cupric oxide you are finding out for this copper only. So plus 2, for Fe2 plus 3. How they have written? H into Au in plus 3, here copper plus 2 for iron plus 3. Okay. Whatever you are finding out oxidation number after the metal, you have to write in parenthesis. Okay. This is what about oxidation number, 5 rules to assign the oxidation number or oxidation state, and stock notation and its significance. Okay. In the coming session or next session, we will see definitions of oxidizing agent and reducing agent in terms of oxidation number, types of redox reaction, balancing of redox reaction. This is very important concept for your examination. I hope you have understood completely whatever I have taught today. We'll meet in the next session. Thank you.